Okay, I'm going to start describing what's going on here. What you're seeing is I'm chucking the part. You see, I've put the workpiece in the chuck. Always make sure you take the chuck key out of the chuck before it moves along. And then we're going to mount the tool. So I put a little shim underneath there to kind of lift it up a little bit. Some of these, the tool isn't quite tall enough. There isn't enough travel on these tool holders, so I put a little bit of a shim underneath. That's about 1/8 inch of a shim, which is just enough on this one, and tighten the at least to start with. That's how these work. You'll notice there's a dovetail on the back side of it, and it will slide into the holder easy enough. So when you see the dovetail there, slide it down all the way to the bottom and move it over clockwise to lock it in place. Now I'm going to show you a little trick here to find your center, so the correct height of your tool. If you hold a scale, doesn't matter what thickness, up against your block and you look at it, you see this one here is a little bit low because it's kicked just a little bit out. So what I'm going to do is back that off a little bit, raise it a little bit, and bring it back in. Looks like I'm going to need to do a little bit more, possibly, because you want it to stand exactly straight up. And there actually looks like it's a little bit over, but that could be the camera angle. So once you're done, tighten all that down. Just thumb tight is good. You don't need to get the wrench out. And then back out. So we got some 1-inch material stock here. One of the things we want to do is there where we just sort of touch. I'm going to move over a little bit to face that. This is looking at the cross slider that moves. By hand, just hold the wheel there, set it at 0. We're going to move it over a little bit towards the part. You'll notice that each one of these marks is 10 thousandths. We're going to move it over about 20 thousandths, and now we want to adjust our RPM to begin with. So we want to run this one. I think we're going to run at about I think it was about 500 RPM is a good round number. So if you look on that dial, you see that we're in the A and high speed, and move to the center position. Now, so we've showing the correct speed there. There we go. And the next thing we're going to do is we're going to, after this, not only the RPM, but now we're going to have to adjust the feed. So looking at that, here's your feed motion lever. When you push that down on this particular one, it's going to, the cross slide will move. So using the chuck to turn it on. If you're going to move your feed, you need to engage your feed. So in this next scene, you're going to see how to adjust your RPM for adjust your feed for the correct tools. For this one, we're going to go for a feed of 10 thousandths per revolution. We're going to you're going to have it in W. You'll be in the U and the S and level 8. So look down below. Here you have feed it in the feed position first. So U and the S and the W, and then we're going to move that, lift the lever up on the right hand side of that to disengage the left hand, move it to 8, and then push it back down, engage it. Go. Once it's fully engaged, the lead screw will turn so it can drive your feed. So now when you engage, you see how it feeds across automatically. So we get a different camera angle here so you can watch it feed across. We've got our tool set there. We feed it up. We just kind of wrap it up by hand, engage, and see how it feeds automatically across. When it's done, you manually disengage, pull that out, and there we got a nice faced end. The next thing we're going to do is deburr. You want to be really careful with this because it is spinning and you could possibly bump your knuckles or worse if you weren't careful. And then we're going to center drill this end. So same RPM. You want to run it at about 1,000 RPM, 750 RPM, somewhere between there. So you've got a good feed, and you want to get into the tapered part of that center drill. I know you've probably seen it listed in books as a combination drill countersink. It is not a countersink. Countersinks are at 82 degrees. This is a center drill. It's at 60 degrees included, so that it mates up with. So now we're going to run the other side. So if you look at your print, you've got this stud that's 5/8 to 3/4 of an inch, and it's about 1.25 inches in length. So we're going to come up here, do the same thing on this end. We're going to face one end, and face this other end, and center drill it. But then we're also going to turn that diameter down so it'll fit in our lathe dogs. So just like we did in the last one, we get it into position. Make sure everything is set where it needs to be. And engage. There it goes. And just like we did before, we feed across until it cleans up. And we're going to change it now to turning, so we need to change our direction. So now it'll turn, and we've turned. We're going to center drill first, so we turn that on. We'll center drill this end as well. And once that's done, we'll move that out of the way so we can turn it. What we're going to do first, we'll bring that up so that we can. So we know where our 0 is there. So we've set that on either our wheel on our carriage. We're going to come up and just touch, back it off a little bit, feed in a little bit, and we'll just take a nice pass so we can get a diameter measured. So we're going to set our cross feed dial to 0 right there. And we're going to go ahead and move off a little bit, turn the spindle on, and we will turn and go in 1.25 inches, just as the print describes. So we engage the feed, it'll automatically feed across. little bit further to get our full length, and then we'll stop and take a quick measurement. We're going to throw our scale up there just to see where we're at. Back that off, shut it down, and we'll throw a micrometer on there to see how much more we have to take off. So now once we've made a record of where we're at now, we're on our zero, we can and in this particular instance, because we're using high-speed steel, I wouldn't take more than 100 thousandths at a time, just because you're going to create heat, you're going to wear down your tool. We don't really have flood coolant to keep it cool. So we're going to go in there, and it'll take a couple of passes, even if you're taking 50, 75, 100 thousandths at a time. We just took a little bit off of there, so you probably got somewhere around at this one we had 250 or 225 thousandths to come off there. So take another pass. Relatively deep pass, probably another 100 thousandths, and we'll get to the end, and just a little bit more, take a little final pass. We should be pretty darn close. So you want to keep your passes fairly consistent in depth, because if you take a couple of heavy passes and then you take a light pass, you're going to overshoot your diameter, because you'll have the built-up pressure, and it will not take as much. So when we're done there, we're going to go ahead and back that off, and throw a micrometer on there, see what our RPM is, or see what our diameter is, excuse me. And we'll throw a mic on there real quick. And if we zoom in on that, you can see that we are pretty darn close to 750. Let's try it again. Take a zoom in a little bit, so you can see the numbers. And there we are, right at like 748, and that's more than adequate for what we're doing on this particular diameter, because all it is for the lathe dog. So we'll go ahead and fire that back up, take it to depth, and then we'll looks like we're going to deburr first. Once again, be really careful when you're doing this. Keep your hands free of the moving parts. And we'll back that off. And the next thing we're going to do is remove this. So we remove the workpiece from the chuck, because we are done with the chuck now. We're going to actually change to make sure you always take the chuck key out of the chuck. Don't ever leave it in there. Someone could turn it on, cause damage. So you're going to look really close. You can see that there are little marks here, and you want those to line up. So what we're going to do, there are six lock keys. So you want to get all of them loose, but leave one in there, and then we'll show you how to lift this out. These things are awfully heavy, so we use the hoist to do that. So we had to show you how to do that in just a second. So right there, they're all. We got one last one to do, so we're going to leave that in place until we get the hoist over here. So we move the hoist in position. First, we're going to take this lifting bar that we have. We just have the one that stays with the hoist. Slide this in, and I'm going to show you something here at this one. I'm going to not stick it in the right distance. See, I've got a little bit sticking out there. Just snug. It doesn't have to be super tight, but it has to be tight enough to hold it. And we'll get the hoist over there, the chain hoist. Sometimes call it a cherry picker. I've never understood why. It's an engine hoist for if you ever work on cars and you're going to swap motors, this is what you would use. Chain onto it, lift it up, get it out. Also has other uses, but particularly what we're doing right here. So this one has been customized to specifically work on the lathes. Maybe a little bit longer arm, but it also makes it a little more unstable when it's got a load on it. So what we're going to do now, we'll reach up in there and I will loosen that last key. Pops into place, but it's still on a little taper that's on the back of that chuck. So to get that loose, I just give it a smack with the bronze hammer, and now that that's loose, I can just shake that. I'll move the tool out of the way so it doesn't. And when I shake that, now watch how this works. See how that tips down like that? You don't want to do that. So I'm going to go ahead and set that on the cross slide. Let it down, and you see how it's sticking out a few inches. You see where that you can see why it's tipping down like that, because we're off center. So I'm going to grab the loosen the hoist so it drops down, and then we will take the chuck key, loosen it, slide that in, tighten it back just snug, because you're going to want to take it out of there once you get the chuck on the floor. And now when you see we lift it up, it's staying nice and balanced. It's setting level. It isn't dipping like that was previously. So something to keep in mind when you're doing that. I want to make sure you guys are aware of that. So now that we've got that on the floor, we've got it out of the way, we're going to put the, we've made sure everything's wiped off, and we're going to put the faceplate on there. Now it's a little bit heavy, but not as bad. So you lift it up, line up the holes, slide that in there, hold it in place while you grab your chuck key, and you give the first one a little bit of a twist. And just sort of snug them down evenly all the way around first time. And then you'll notice I also go through a second time to make sure they're all have, once they've seated, they've got equal tightness so that they don't come loose while I'm. So this takes a minute or so to go all the way through that. And then in the cart that each one of these lathes has, each one has their own cart with the own chuck and faceplate and other multiple tool holders in the cart for each one. Each one of the carts is numbered that identifies with the lathe as well. So in there you've got an adapter and a dead center. Dead center means it doesn't spin, it moves at the same RPM. So we're going to wipe out, make sure there's no chips in there. I usually use a rag first and then reach in there with my finger just to wipe around a little bit, make sure there's nothing else. I've wiped this off and then give that a swift slap in there, and it locks in place. Here we're going to remove the chuck from the tailstock and replace it with the live center. So we move that back, and once you move that into the back position, make sure you just kind of make sure everything's in place, wipe it down, stick your finger in there, make sure there's no chips or anything, usually it's not, and fit in there. And once again, that one you pop it into place and the taper will hold it in direction. And this one, the taper, the center rides on ball bearings, so it's actually known as a live center because it spins. Okay, now we're going to load our workpiece into the between centers now. And the nice thing about this is, you want to make sure your chuck, this is known as the lathe dog, make sure that arm is facing to the left so that it fits into the faceplate. We got it loose for right now. We'll make sure there's room to get your tools in there and get everything tightened, and then I'll grab lock your tailstock in there, tighten the tails, tighten it up, and tighten the tailstock down. You've got two levers, one that moves the entire tailstock, the other one locks the spindle on the and then you want to make sure that lathe dog engages into that faceplate, and there's plenty, it's moved plenty ample space away from the cutting area so you can get your tool in there without running a problem. And you tighten it up, and you want it pretty darn tight because you don't want it to move while you're turning. You will be cutting threads on this particular workpiece, although the process for just turning, like your first one with the bushing knockout, will follow this exact same procedure. You'll cut it to length. You'll do a little bit of knurling on that one, which will show you that when you're in the shop. Got some other videos hopefully will get done. So one of the things we did was painted the lathe dogs a bright safety orange so you could see while they're spinning. That way you'd know where it is, so you wouldn't get your fingers close to that, because it hurts if it smacks you. And so you want to keep your fingers away from any moving pieces. And same thing here, we want to turn that diameter. Your first major diameter on this one is 7/8. So we took a little cut, throw the micrometer on there, make sure where we're at, because we're taking about 1/8 inch off of the OD since we're going from 1 inch to 7/8. And we'll see where we are and how much more we need to take off. And we want to do this in probably like 2 passes. And we kind of bypassed all the other steps because it's, turning is turning. It's not that interesting. Now we're going to put a little bit of a groove in there. Now for each one of these, you're going to have to figure out how deep your minor diameter of your threads are. And look that up in your book. Figure that out for each thread that you're going to be cutting, and that's how deep you want to go. And so this one, we're going to do a couple of these, and I got in kind of a hurry here, so you will notice that a couple of these diameters I messed up on a little bit. You'll see that as we come up. These two are okay, but I lost track of where I was at, or didn't do the math right, and cut it a little bit too far when I was turning it, or took too deep a pass, depending on which ones we're doing. And so with this one, each one of these cutoff blades that I'm using to groove for your thread relief is about 1/8 inch wide. So what you're going to have to make 2 passes for this 1/4 inch thick. So you have to come in touch and move over 1/8 of an inch, come into the same depth as you see I'm doing right here. But you'll have that on your dial. So you do that, and once you get that second one to depth, bring it about halfway so you can take out that little bit of in the center. It isn't quite 1/8 inch wide, so that way we got a full 1/4 inch of thread relief. You don't probably need that much, but that's what's on the print, and we want to make sure you guys have plenty of room when you're done threading, that you have time to disengage. And here's the last one now. You can see over there on that 5/8 diameter that I had cut it a little bit too far. Same thing with this, with the 9/16 diameter. I'd gone a little bit farther than I should have rather. And so I make mistakes too, but you get the gist of what's going on here. So in this next stage, we're going to set up your tool. Now these tools will already be ground. We'll make sure these are ready for you with each one of these. And what you want to look at is, and I put the piece of paper underneath there because it's easier to see that there you go. And so use this thread gauge. So a lot of times you hear people call it a fish scale, but it's a gauge for setting your tool to make sure you are in the right. And I put the white piece of paper underneath there because it's easier to see against that white background that if there's any misalignment. So sometimes it's easier to just put that on there, and if there's any movements that need to be made, this looks like it's in the right spot now, so I'm going to go ahead and tighten it down. And so now that's right where it's supposed to be. And then we want to set for our threads. This first thread that we're going to do here is a 7/8. So there you see that your compound rest is set at 30 degrees off of that 90 degrees, so 60 degrees off center, so that when you're feeding your tool in, and then we look in here and we want to move into position so you can see where the threads are. I need to go a little bit more to the left because that's still there we go. So we're going to set the threads, inch threads. We're going to do 9 threads per inch, so we've got to have it in W, and we'll set it at U and T. So you remember earlier when we set our feeds, this is threading is just a coarser feed, and 2. So what we're going to do there, we want to look at, see, there's our W, there's our U. Look up here, it's on T, and the last thing you want to set is 2, and you see that's been moved in place. So now we are set up to cut 9 threads per inch, and we want to set our RPM. We want to run low, so we're going to actually run it about as close to 50 RPM as we can, because I don't want to move real fast, because you've got to disengage that thread as it's moving along. So if you look, we want to be in the A, and low gear, and the A gear, and set in the center. So now you see it's moving nice and slow. That's how fast you want to go. And the reason I moved it to that position, I wanted to make sure I had plenty of clearance to get my tool all the way in there and across. So as well as spinning, I'm going to go ahead and paint this with some Dykem so I can see where my first cuts are when I get ready to do that. So we move off to the side there. There you go. Let that move that in place. We're going to move over. Come in and just touch. Move to the right. Oh, I guess first we're going to make sure that that's on. So exact same procedures. I'm not going to go into great detail with this one. Same thing, just make sure we're still on center. We appear to be. So I'm going to go ahead and back that out. Adjust everything nice and smooth. Adjust our settings down so everything's in place. Lock it all down. Now it's been locked down. We'll move in, touch, move to the right. We're ready to engage. So we'll go ahead and set our zeros on, just like we did before, setting our zeros on our compound and our cross feed, or cross slide rather. So the cross slide is set, compound is set. We engage, and then we look at our half nut. And unfortunately, I forgot to film that, but we can show you that. So we want to engage. I prefer to engage on the same number each time. That way I know it's always going to engage in the right place. Should be, honestly, as fast moving, you don't have to wait that long for it to come around and engage. In fact, a lot of times you have to pretty much hurry to get it where you want it. So as soon as it's moved to the point where you can engage it, there it goes. And we're going to take this very first pass to make sure that we have the correct number of threads when it gets to the end. See how close we're getting to that lathe dog, and then you have to disengage your cross feed. And do that by hand. We'll stop, and we will slide the thread gauge, which is set at 9 threads per inch, and see how easy that is to read now that it's got that dicom in place. Not as easy to do when there isn't any dicom on there. Not as easy to see. So now we're going to feed in a couple thousandths at a time. As it starts getting deeper, we're going to go in even less. And in fact, on the last ones, you'll probably take 1,000th depth of cut, and you might take 2 or 3 passes to get all of the tool pressure, so that you're getting a nice clean cut, because you don't want to just keep building up on pressure and ripping your threads. So waiting for that line to engage the correct point on the half nut, and there we go. Right, I'm going to see it's following that line exactly each time. And as soon as we get thin, we back off on the cross slide, feed in 1,000th or so on the compound, and wait for the line, and then we engage again. And as soon as it's in this point, it'll drop into place. See, once again, it's following the exact same line each time, and that's what you want to happen. You want to see a nice curl like that. You want it to so I'm going to feed that off, come over here, come back in, and we're going to bypass all the times to do this because it took about 30-40 minutes to get all the way through it. So now we're down to the bottom. We're at where we've left, and you'll have to do the math to figure that out. There'll be some lessons for you to fill out, doing that, figuring out depth of cut, that sort of thing. And so there we are, feeding across, taking some empty passes, cleaning those cuts out so that those threads are nice and clean. And finally, your last few passes. Time, and we'll stop. Looks like we're going to do a couple more passes. And, these are obviously, you're not feeding anything in, you're just letting the tool pass in the exact same depth so that it takes up all the pressure. So now we'll look at this, and you're going to look at the chart, figure out which thread wire to use. So 7/8 9, we're going to use a 63 thousandths wire, and our measurement over wires for this particular thread, for a class A thread, or 3A, class 3, you want, you're right, so you'll see that in your ready reference that you'll be using in the shop. I'll let you have one of those. And looks at like our pitch diameter is going to be 802.8 to 798.1. So you get quite a opening to get with. And the wires here, I'll show you those here in a second. So looking at this, you can see a pitch diameter, major diameter, minor diameter, all this good information. There's your numbers that you want to have. And we'll also make sure you know how to do the right formulas for figuring out the math out that way. There's a thread wire set, and there's your 63 thousandths wire. And that is it. We'll go over things in class. Thank you for watching, and we'll see you again soon.